Hello and welcome, dear mathletes, once again to Mathlete Minds. We continue our journey of coordinate geometry completely related to class 10 CBSE syllabus. In this video, which is an extension of the section formula, we'll be discussing some more applications of the section formula. In the previous video, we had understood the simple applications of section formula and the concept of section formula. Here, let us take up some more questions based on the section formula. So the first question that we have over here is determine the ratio in which the straight line x minus y minus 2 is equal to 0 divides the line segment joining the points 3, minus 1 and 8, 9. So the points A and B have been marked. This is a representative figure. It's not a real figure over here. And then we have another straight line x minus y minus 2 is equal to 0. The points AB have been joined and we get the line segment AB. Now this line x minus y minus 2 is equal to 0 is intersecting AB at the point C. Let the coordinates of the point C be x1, y1 and let it divide the line AB in the ratio m is to n. The important thing to be remembered over here or to be understood over here is this point x1, y1 not only lies on the line AB, but it also satisfies the line x minus y minus 2 is equal to 0. It is a point of intersection. So this is the basic fundamental principle that we'll be taking over here to solve this particular question. So first of all, we are going to write down the values of x1, y1 in terms of m and n using the section formula. So x1 will be equal to 8m plus 3n by m plus n. And y1 will be equal to 9m minus n by m plus n. So now we get back to the equation of the line x minus y minus 2 is equal to 0. And here we'll be substituting. For x we will be writing the value of x1 and for y we'll be writing the value of y1. So here we get 8m plus 3n by m plus n minus 9m minus n by m plus n minus 2 is equal to 0. Now let's simplify this by taking the LCM. So this becomes 8m plus 3n minus 9m plus n minus 2m minus 2n is equal to 0. M plus n is the LCM. It goes to the right hand side and becomes 0. Here the sign minus becomes plus because we have the minus sign outside, and after taking the LCM, this will become plus multiplied by a negative from outside. And this also becomes 2m minus 2n because again here we have the negative sign. So now 8m minus 9m minus 2m, that will give us minus 3n. And 3n plus n minus 2n, that will give us plus 2n. So this is equal to 0. So minus 3m is equal to minus 2n. So m is to n is equal to 2 is to 3. So the ratio in which C divides the line AB is 2 is to 3. Now to get the coordinates of the C x1, y1, we simply have to put, for m we will put here 2, for n we will put here 3. So this becomes 16 plus 9 by 5, that is 25 by 5, so x1 is 5. And this becomes 18 minus 3, that is 15 by 5, so this is 3. So the coordinates x1, y1 are 5, 3. So this is how this question needs to be solved. The next question is, the points 3, minus 4, minus 6, 2 are the vertices of the extremities of a diagonal of a parallelogram. If the vertex is if the third vertex is minus 1, minus 3, then find the coordinates of the fourth vertex. So here this is again a representative figure, and important thing to be remembered over here is extremities of the diagonal. So you can take either of the diagonal AC or BD. I have selected AC. And these are the two endpoints minus 6, 2, 3, minus 4. The third vertex is minus 1, minus 3. It can be either B or either D because this is only a representative figure. Now, in a parallelogram question, the important thing to be remembered is the property of the parallelogram, which states that the diagonals of the parallelogram bisect each other. That means AO is equal to OC and BO is equal to OD. So now we'll take the help of this property and first calculate or write down alpha beta in terms of the diagonal AC and alpha beta in terms of the diagonal BD. So if I write down alpha in terms of the diagonal AC, because it is bisecting this diagonal AC, so here alpha, when I take the diagonal AC using the midpoint formula, will be minus 6 plus 3 by 2, and beta will be equal to 2 minus 4 by 2. And if I take the diagonal BD, alpha will be equal to x minus 1 by 2, and beta will be equal to y minus 3 by 2. So now, because alpha and beta are the same points, we can equate the values. So we get here minus 6 plus 3 by 2 is equal to x minus 1 by 2. And for beta, we can write 2 minus 4 by 2 is equal to y minus 3 by 2. So this 2 and 2 gets cancelled. We are left here with minus 3 is equal to x minus 1. So x is equal to minus 2. And this 2 and 2 gets cancelled. So minus 2 is y minus 3. So y is equal to plus 1. So the coordinates of the vertex B are minus 2 comma plus 1. So here the important property that we have used is the diagonals of the parallelogram bisect each other. And secondly, when we get the question extremities of a diagonal, it must be seen to it that we mark the points at the correct positions so that there is no mistake in our calculation. The next question is, prove that the midpoint of the hypotenuse AB of a right angle triangle BOA is equidistant from its vertices OA and B. Here we are asked to prove this particular statement, that is, the midpoint of the hypotenuse is equidistant from the three vertices. Now, in this case, the representative figure is given, the coordinates of the points are also given, but if we get a question without the figure given, then the best thing that we can do is we can choose the axis as two sides of the right angle triangle so that the origin becomes one of the vertices. And the two axes, when we take the two axes, because here the coordinates are given on the x-axis, the y coordinate is 0, and the y-axis, the x coordinate is 0. So now first thing that we need to do is C is the midpoint of the hypotenuse AB. So to proceed with, we'll calculate the value of x1, y1 using the midpoint formula in terms of A and B. X1 will be equal to 2A plus 0 by 2, that is A. And y1 will be equal to 0 plus 2b by 2, that is equal to b. So the coordinates here become AB. Now we have to prove that CO is equal to CA is equal to CB. So CO will be equal to, coordinates of the origin are 0, 0. So CO will be equal to A minus 0 the whole square plus b minus 0 the whole square under root. So this becomes equal to root over a square plus b square. Now if I take CA, CA will be equal to a minus 2a the whole square plus b minus 0 the whole square under root. So this becomes equal to root over a square plus b square again. Why a minus 2a is minus a the whole square is a square. CB will be equal to a minus 0 the whole square plus b minus 2b the whole square under root. So this becomes root over a square plus b square. So all the distances are the same. First thing that we had to do was find out the coordinates of C, the midpoint, in terms of the coordinates of the hypotenuse endpoints, that is A and B. So that is the fundamental principle that we need to understand over here. The next is related to centroid of a triangle. Now, coordinates of the centroid of a triangle can also be obtained with the help of the section formula in terms of the vertices of the three vertices of the triangle. So here the coordinates of the vertices are x1, y1, x2, y2, x3, y3. First, let us understand what is the centroid. Centroid is the point of intersection of the three medians of the triangle. Here the medians are AD, BE and CA. Another important aspect of the centroid is the centroid divides the median in the ratio 2:1. All the three medians. Now here I have written 2 is to 1 for AO is to OD. It applies for BO is to OE also. It applies for CO is to OF also. The bigger ratio 2 is towards the vertex and 1 is towards the opposite side of the triangle. So in order to calculate the centroid of a triangle, what we need to do is first let us find out the coordinates of D. You can take any other median. I am taking the median AD. Everywhere, in whichever median you take, the answer will come the same. So first of all, we'll find out the coordinates of D. Coordinates of D are x2 plus x3 by 2 using the midpoint formula and y2 plus y3 by 2. So now O divides the median in the ratio 2 is to 1. So here supposing the coordinates of O are alpha and beta. So alpha will be equal to 2 into x2 plus x3 by 2 plus 1 into x1 divided by 3. So this becomes equal to 2 and 2 gets cancelled. You are getting x1 plus x2 plus x3 by 3. And then beta will be given as 2 into y2 plus y3 by 2 plus 1 into y1 by 3. So this becomes equal to 2 and 2 gets cancelled. Again y1 plus y2 plus y3 by 3. So the coordinates of the centroid are, with the help of the vertices, are given as the sum of the three x coordinates divided by 3, and the second coordinate beta is given as sum of all the y coordinates divided by 3. So this is the simple formula for the coordinates of the centroid of the triangle. Now let's take the next question. Two vertices of a triangle are 1, 2 and 3, 5 and its centroid is at the origin. Find the coordinates of the third vertex. So here this coordinates of the centroid are given as 0, 0. We have to find the third vertex over here. So we'll do the simple application of the formula of the centroid. Alpha is equal to x1 plus x2 plus x3 by 3 and beta is equal to y1 plus y2 plus y3 by 3. So now alpha is 0. So 0 is equal to 1 plus 3 plus x3 by 3 and 0 beta is also 0 is equal to 2 plus 5 plus y3 by 3. So this becomes, this is reduced to 0 is equal to 4 plus x3 and this becomes 0 is equal to 7 plus y3. So x3 is equal to minus 4 and y3 is equal to minus 7. So the third coordinates or the coordinates of the third vertex are minus 4 comma minus 7. I hope this is clear. It was a very simple application of the centroid formula. The next question is, if the coordinates of the midpoints of the sides of a triangle are given as 3, 4, 4, 6 and 5, 7, then find the vertices. So here these points are the midpoints of the three sides of the triangle. ABC is the triangle representative figure over here, and we need to find the coordinates of the vertices. So what we do is we take each of the midpoints separately. Like if we start with the side BC, the midpoint is D. So I can write using the midpoint formula 3 is equal to x2 plus x3 by 2 and 4 is equal to y2 plus y3 by 2. So from here we get 6 is equal to x2 plus x3 and 8 is equal to y2 plus y3. Now we take the side AB, and in a similar way I can write down here 8 is equal to x1 plus x2 and 12 is equal to y1 plus y2. If we take the side AC, we'll get here 10 is equal to x1 plus x3 and we'll get here 14 is equal to y1 plus y3. Now we get three equations in terms of x and three equations in terms of y. So let us add all the equations in x and all the equations in y separately. This is equation number 1, this is equation number 2, this is 3, and this is 4, this is 5, and this is 6. So if we add this, we get over here 1824 is equal to 2x1 plus 2x2 plus 2x3. And this will be 26, that is 34, is equal to 2y1 plus 2y2 plus 2y3. Now this on simplification will give us 12 is equal to x1 plus x2 plus x3, and 17 is equal to y1 plus y2 plus y3. So here there is one tip also, like if you are asked the coordinates of the centroid, you need not proceed and find out x1, y1 and x2, y2 and x3, y3. From here itself, the coordinates of the centroid can also be obtained. We know coordinates of the centroid are x1 plus x2 plus x3 by 3. So the left hand side also, if we divide by 3, we'll get here 4. Similarly here, this will be 17 by 3. But we have to find here x1, y1, x2, y2 and x3, y3. So now let us take the first equation, x2 plus x3. x2 plus x3 is 6. So if I put here 6, I will get x1 is equal to 6. 12 minus 6 is 6. Similarly, y2 plus y3 is 8. So if I put here 8, I'll get y1 equal to 17 minus 8, that is 9. Now let us move on to the second equation. x1 plus x2 is 8. We get the value of x1 as 6. So x2 will be equal to 8 minus 6, that is 2. Similarly, y2 will be equal to 12 minus 9, that is 3. And if we take the value, if we put x1 in the third equation here, we'll get here x3 is equal to 10 minus 6, that is 4. And y3 will be equal to 14 minus y1, that is 9. So we get here 5. So the three coordinates, if we put them in the right perspective, we'll get here 6, 9, 2, 3, and 4, 5. So these are the three coordinates, the coordinates of the vertices of the triangle. The next question is, if x minus 2y plus k is equal to 0, is the median of a triangle whose vertices are at points minus 1, 3, 0, 4 and minus 5, 2. Then find the value of k. So here, important thing to be understood is this is the equation of a median. It can be any one of the three medians. It can be AE. Supposing I mark over here this as E. This is BF, and this is let me take it as EF and G, CG. So now we get over here the coordinates of the this point D. That is, as I was saying, this median can be any of the three medians. But the this point, that is the centroid, will lie on any one of the medians. Sorry, it will lie on all the three medians. So what we need to do over here is find the coordinates of the centroid. So alpha will be equal to, if we start from here, minus 5 plus 0 minus 1 by 3, that is equal to minus 2. And beta will be equal to 2 plus 4 plus 3 by 3, that is equal to 9 by 3, that is equal to 3. So the coordinates are minus 2, 3. Now this point will lie on this median, because this the centroid lies on all the three medians. So we put the value there, x minus 2y plus k is equal to 0. If I put here minus 2 into 3 plus k is equal to 0, I'll get here minus 2 minus 6 plus k is equal to 0. That means k is equal to plus a. So this is how we get the value of k. So the point to be understood here is this median, this equation of the median will be justified or satisfied by the coordinates of the centroid of the triangle. So with that, we come to the end of this video. Hope you like the explanation. Kindly like, share and subscribe to the channel. Thank you for watching. Please give your comments for the explanation.